Section 10.2 is on measuring angles and arcs. Lots of definitions to start off with here. The central angle of a circle is an angle whose vertex is the center of the circle. So for example, in this circle here, in circle C, angle ACB is considered a central angle of circle C because that angle contains the center of the circle, which is C. The sum of all of the central angles of a circle is 360 degrees. And you may be aware of this from pre-algebra or previous math classes. All of the angles in a circle will add up to 360 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360. An arc is a portion of the circle defined by two endpoints. So in circle C here, arc AB is an arc of circle C. I kind of like to think of an arc as the pizza crust from a pizza. The measure of an arc is the same as the measure of its central angle. So if the measure of angle ACB is 85 degrees, then the measure of arc AB is 85 degrees as well. A minor arc is an arc whose measure is less than 180. A major arc is an arc whose measure is greater than 180, and a major arc must always be named by 3 letters. We'll take a look at that in a minute. A semicircle is an arc whose measure is 180. Its endpoints lie on the diameter. So, looking at this diagram here, AB would be a minor arc because it's less than 180. BC is also a minor arc. Arc ACB is a major arc. And notice that it has to be named with 3 letters. A is one endpoint, B is the other endpoint. But since I want the major arc and I want it to go all the way around here, I have to start at A, move around, grab C, and stop at B. If I just called it AB, then I'm referring to this minor arc. And a semicircle, you can call it AC, and it doesn't really matter which way you go, or ABC. And a semicircle is basically just half a circle. Here's a theorem. 2 minor arcs are congruent if and only if their central angles are congruent. So if angle AMB, I'll go ahead and mark it here. If angle AMB is congruent to angle CMD, then arc AB is congruent to arc CD. And conversely, if arc AB is congruent to arc CD, then angle AMB is congruent to angle CMD. Adjacent arcs have exactly one endpoint in common. So looking at circle M here, arc AB and arc BC are adjacent arcs because they share point B. Arc AB is right next to arc BC, so they're adjacent. And the arc addition postulate, kind of like we had segment addition postulate and angle addition postulate way back in chapter 2, says that if AB and BC are adjacent arcs, then the measure of arc AB plus the measure of arc BC is equal to the larger arc ABC. So AB plus BC equals arc ABC. So let's take a look at several examples here. So here we have a circle. I don't have the center labeled, so I don't have a name for it, but it has points on it A, B, and C, and we have to find X. In other words, what is the measure of that central angle right there? Well, I'm given that one of these angles is 120, and I know that because of this little angle, this little right triangle thing here, I know that this is a 90-degree angle. So in order to find the measure of this arc here, I'm going to do 120 plus 90 plus X, and all of those angles have to add up to 360. So X is equal to 150. So remember, that refers to the measure of this angle and also the measure of arc BC. The measure of arc AC, because we have this angle, central angle here that's 120 degrees, the measure of arc AC is also going to be 120 degrees. And the measure of arc CAB, so that means we start at C, go around to A, and continue through B, is going to be equal to 120, which is arc AC, plus 90, which is arc AB, which gives me 210. Okay, here's circle P, and we're told that segment AB and segment CD are diameters. Remember, if that's a diameter, it's cutting this circle in half. So from A through D, E, and B, that would be considered a semicircle. Also from D through E, B, and stopping at C, that would also be considered a semicircle. We're also given that the measure of angle CPB is 20, so I think I'll go ahead and mark that in here, and that the measure of angle DPE is 60. So, given these following arcs, we have to identify each as major or minor and then find its measure. Actually, what I would like to do right now before we go any further is actually label what we know in the triangle here, or in the circle here. I was given that this was 20 and this is 60. Well, since AB and CD are diameters, this angle over here must also be 20. And since CD is a diameter, let me go back. Those are 20 because they're vertical angles, and you can have vertical angles in a circle as well. So, and since I know that CD is a diameter, I know that this here from C through B and E has to add up to 180. 60 plus 20 is 80. So this angle here must be 100 degrees. And then I also know that since CD is a diameter, this over here must be 180 degrees. Subtract 20 from that, and that gives me this angle over here is 160. So this kind of reminds me of some of the triangle problems we used to do back in chapter 4 and 5, I believe it was, where even before you start to look at the problem, just label everything you know. Label what you're given and then label what you can figure out. So let's look at these. Number 1, arc AD is obviously a minor arc because it's less than 180, and its measure is 20 degrees. Arc BE is also a minor arc, and its measure is 100 degrees because its central angle is 100. Arc BCA, so from B through C and stopping at A, that one's actually going to be a semicircle because AB is a diameter. And the measure of every semicircle is 180 degrees. Arc CDA, so start at C, go around through D and stop at A. Well, from C to D is 180. Add another 20 to that, and that's going to give me 200. Oops, I forgot to write that that is a major arc. Let's move that back over here. That's a major arc because it's more than 180 degrees. And arc ECA, so starting at E, excuse me, going around through C and over to A. So 100 plus 20 plus 160 adds up to 280. So that is also a major arc. And our last concept here is probably the most difficult to deal with, and that's the idea of arc length. We just spent a lot of time talking about arc measure. Arc measure is in degrees, and it's based on the central angle of the circle. Arc length is actually a distance that we can measure. It's the distance between endpoints along an arc. It's measured in linear units, such as inches, centimeters, miles, feet, and it is a fraction of the circumference of a circle. So picture this. So you have a pizza, and you have a couple of slices, and you want to measure how long the crust is on several of those slices. So you actually take a tape measure, and you lay it down, and you measure along, and it will tell you that that's, I don't know, 10 inches or something. That 10 inches is a fraction of the entire circumference of the circle. So here's the formula we use. L, which stands for arc length, is x over 360, where x is the measure of the arc, times 2 pi r. What is this saying? If the measure of the arc is a certain number of degrees, we're going to divide that by the total number of degrees in a circle, which is 360, and then we're going to multiply that by the circumference. So the arc length is a fraction of the circumference of a circle. So let's take a look at a couple examples here. If the radius of circle P is 5 inches, find the exact length of each arc. Okay, so to find the length of arc AB, I'll use L for length. I'm going to use the measure of arc AB, which is 120, because angle APB is a 120 degree angle, over 360, times the circumference of the circle, which is 2 pi times the radius, which is 5. Now, to get the exact length of the arc, you're going to leave pi in your answer. Okay, so I'm going to grab my calculator and I'm going to do 120 divided by 360 times 2 times 5, and this one actually ends up being a fraction, so I need to do math, enter, enter, and I get 10/3 pi, and this needs units on it, inches, because the radius is 5 inches. So again, the measure of the angle, or the central angle or the arc, divided by 360 times the circumference, multiply and divide, in other words, deal with all of the non-pi numbers, turn that into a fraction if necessary, or a decimal if it's an exact decimal. Put pi after it, and that's in inches. Let's take a look at arc BC. The length of that is going to be the measure of arc BC, which is 90, because I have that little right angle symbol in there, divided by the total degrees in the circle, 360, times the circumference, 2 pi r. Putting that into my calculator, 90 divided by 360 times 2 times 5 gives me 2.5. Tack the pi on the end, and inches. And I decided to go with the decimal for this one because this is actually a terminating decimal. And arc ABC, so that's the major arc that starts here at A, goes through B, and stops at C. So the length of that arc is going to be, that adds up to 210 degrees out of 360 times my circumference, 2 pi r. In my calculator, I do 210 divided by 360 times 2 times 5. Math, enter, enter. I get 35 over 6, tack a pi on the end, and inches. So the difference between arc measure and arc length is arc measure is based on the central angle. Arc length is based on the circumference. It's a fraction of the circumference. This lesson was very heavy in vocabulary. If you need to make flashcards, go back and do that, but just make sure you're familiar with all of these terms because we're going to continue to use them throughout